Good morning, class. We're looking at angle pairs and parallel lines. So the question we ask ourselves is, what is the relationship between angles formed when parallel lines are cut by a transversal? Your learning intention: I'm learning to find unknown measures when parallel lines are cut by a transversal. You have two warm-up questions. Can you finish those on your own? So pause the video and see if you can get those finished. Okay, so for your warm-up, points x, y, and z are collinear, and xy plus yz equals xz. Which statement below is a counterexample? So if we're looking at this, it's something like this. We don't know how big the segments are. We don't know how big the segment pieces are. But we're going to look at these statements and see if they could be true or not. xy. Can xy be greater than xz? No, because xz is a whole and xy is a part. Can xy be less than xz? Yes. Can xy be less than yz? Well, yeah, it can, because we're not sure which is bigger. And so if this one's true, the opposite can also be true, because we don't know the size. We just know where they're located at. Okay, now, point H lies on the segment GH with GJ on the segment GJ. If GJ is 35 meters and GX is equal to 2x plus 7, what is the value of x given GH and HJ are congruent? Draw a picture to help solve. Okay, so the first thing we do know is this whole thing is 34. We know that GH and HJ are congruent. So 2x plus 7 is what both of those are. But we also know that this whole thing is 34. How do we use that? Well, piece plus piece makes a whole. 2x plus 7 plus 2x plus 7 is equal to 34. 2x plus 2x is 4x. 7 plus 7 is 14. 4x plus 14 equals 34. Okay, let's solve. I'm going to subtract 14 from both sides. 4x will equal 20. When I divide by 5, then x will equal, when I divide by 4, then x will equal 5. So we have found x. We can find the missing pieces. They'll both be 17, because 2 times 5 is 10, plus 7 is 17. And we're done. Parallel lines. What are parallel lines? If you look at the wall, the intersection of the ceiling and the wall, that would be one line. Then intersection of the floor and the wall could be another. And those would be parallel, example of parallel lines. But if we have to define that, how do we define that? The major thing you have to remember, to be parallel, they also have to be coplanar. Parallel lines are coplanar lines that never intersect. Transversal. What is a transversal? A transversal is a line that intersects two or more lines. As you notice, we don't say parallel lines because they don't have to be parallel for it to be a transversal. They just have to intersect. And finally, skew lines are lines that, well, they're not parallel, but they don't intersect either. So if they're not parallel and they don't intersect, what else do we have to put in this? Lines that are not coplanar. And never intersect. So if you're looking at skew lines will be one above the other. Parallel lines have to be in the same plane. Skew lines will be one above the other, and if you're looking at it like this, these are skew, they will never touch, but neither are they parallel. Corresponding angles are angles that are in the same position. When lines are cut by a transversal. Okay, so if you're looking at parallel or corresponding angles, in this case the lines are parallel, but they wouldn't have to be. Corresponding angles are simply angles that are in the same position. So if I want to look at angle 1, okay, angle 1 is at the line, and it's the top of the line, and it is to the left. So I come down here. Which one is at the top of the line and to the left? That would be angle 5. So I know that angle 1 and angle 5 are corresponding. What about angle 2? Angle 2 is to the top and to the right. When I come down here, to the top and to the right is angle 6. So I know that angle 2 and angle 6 are corresponding. Okay, that takes care of all the angles at the top of the line. What about underneath? I'm looking at 3. 3 is underneath and to the left. Come down here. Underneath and to the left is 7. So angle 2 and angle 7. Angle 3 and angle 7. And then that takes me to the last one, pairs. 4 and 8. Okay, so if you notice, it jumps down, jumps down, jumps down, jumps down. Okay, so we've got all those corresponding angles named. That brings us into the postulate. Why is it a postulate? Because we can never ever prove all of the examples we could give, because we could have an infinite number of examples. So we have to accept a postulate as true without being proven. Okay, when two or more, what kind of lines do they have to be? Parallel. When two or more parallel lines are cut by a transversal, then the corresponding angles are congruent. Okay, let's start looking at the different pairs of angles we can have. If we're looking at alternate interior angles, we're looking at 3 and 6, 4 and 5. They are going to be congruent also. Alternate means going from side to side. Interior means in between the two parallel lines. So angle 3 and angle 6. And then angle 4 and angle 5. Okay, same side interior angles. Well, we know they can't be congruent because in most cases they cannot be congruent because the alternate interior angles are. So your same side interior angles will be supplementary, because if they form a line, they'll either be congruent or supplementary. So anytime you've got a line, you know that the angles that make that line will be supplementary. And this is what's going to also happen in all the different angles that you find in parallel lines. So your same side interior angles would be angle 3 and angle 5. And then angle 4 and angle 6. Okay, what about our alternate exterior angles? So if I'm looking at alternate, I'm looking at 1 and 8, I'm looking at 2 and 7. What do you think? How can you prove that? Well, if I'm looking at angle 1, I know that angle 1 is congruent to angle 5 because they're corresponding. Angle 5 is congruent to angle 8 because they're vertical. So alternate exterior angles are congruent. Angle 1 and angle 8. And then angle 2 and angle 7. So if you're looking at these parallel lines, I know that 1 and 5 are congruent, 5 and 8 are congruent, 8 and 4 are congruent. Their corresponding and vertical angles will always be congruent. So you're going to split these 8 angles into 2 congruent sets. Same side exterior angles, they cannot be congruent, so they must be supplementary. List the same side exterior angles, 1 and 7, angle 1 and 8, angle 7. Okay, angle 2 and angle 8. Okay, any questions? Okay, so when you get ready to find all the missing angles, you can find 4 of them without any math at all. No math. If this is 67, I know one is also 67 because they are corresponding. I know that this one is also 67 because it is vertical. This one's 67, so this one will be 67 degrees also. Done. I've got 4 of them done. 180 degrees minus 67 degrees is equal to what? $113 is correct. So, all the rest of these will be 113 degrees. Done. Okay, pause the video. Can you do the last one on your own? Without any math at all, which ones can we identify? If this is 83, then this will be 83 also. They're vertical. If this one's 83, then this one will be 83 also. Corresponding. If this one's 83, 83 here. So, we've got 4 of them done. All we need to do is find the other 4. 180 degrees minus 83 degrees will give me 97 degrees. Everything else will be 97 degrees. Any questions? So if you notice, the congruent angles kind of form a sideways Zorro Z. Dead up, boom boom, or boom boom, boom boom. So I know I'm successful when I can find missing measures of parallel lines cut by a transversal. So this is parallel lines and angle pairs.